In this video, we're going to cover section 8.4, selecting the required sample size. So this is really important. We're going to be trying to determine the required sample size when we're estimating the mean mu or the population proportion p. And what this means is we want to know how many people we have to ask, or how many people we need to survey, or how many things we need to observe that would fall within what we're looking for. So here's the formula for when estimating mu. What we need is we need the associated z-score, the associated sigma, and the margin of error. Now, if we don't know the sigma, we can actually use the range and divide it by 4. If we're looking for the population proportion, how many people we need to ask or how many things we need to observe, we need the z-value, the margin of error, and the sample proportion. But if we don't know the sample proportion, then we estimate 0.5. And what's really important here is that no matter what, we're going to round up because we're dealing with people and observations. You can't have 0.1 of a person or 0.1 of a study sample, so you want to make sure that you always round up, kind of forgetting your rounding rules. So again, we just covered this when we're dealing with the population mean. So let's do an example here. Jared Bean wants to construct a 90% confidence interval for the mean of all ultra green cars. Suppose Jared would like to constrain the margin of error to within 2 mpgs. Further, he knows that the minimum mpg is 76 and the maximum is 118. How large a sample, so that's n, we don't know n, does Jared need to compute the 90% confidence for the population mean? So basically what this is saying is, hey, what's the n when we're looking for mu? So the formula for that is n equals the z-score associated with that confidence level, with the sigma, over the margin of error squared. So let's see. Do we have the z-score? Well, we know it's 90% confidence, so the associated z-score would be 1.65. Oops, sorry, 1.645. We actually don't know this. They don't tell us anything in here. But we do know that the margin of error he's interested in is 2. So when we don't know the mean, when we don't know the sigma, we use the range divided by 4. So he actually gave us the minimum and the maximum. Remember that the range is max minus min. So we would estimate this to be about 118 minus 76 over 4. And make sure you calculate 118 minus 76 first. Hit enter, divide by 4. You should get 10.50. And now we can calculate the n, or the sample size needed. So our z value is 1.645 times, we're going to use 10.54, and our margin of error is 2. It's really important you square it last. So when we calculate this, we're going to do let me clear all this out, 1.645 times 10.5 divided by 2, and then I'm going to square it. And I get 74.6, right? 74.6. But remember, we're always going to round up. So Jared needs to use a sample size of at least 75 cars if he wants it to meet these other conditions. And there's it written out for you. Now, what if we want to estimate for the sample size for the population proportion? So in example 2, Jared wants to construct the 90% confidence interval for the proportion. Now, we're not talking about the mean, we're talking about p, that of all ultra green cars that obtain over 100 miles per gallon. Jared does not want the margin of error to be more than 0.10. So we've got our margin of error. How large a sample does Jared need for his analysis of the population proportion when we're given p? So when we're looking for n, for p, we use this formula here. We have our z-score associated with our confidence level over the margin of error squared, and then we multiply that by p hat, the sample proportion, times 1 minus p hat. So we need our z-score. So in this case, it's a 90% confidence interval, so that's 0.10, 0.05, and we know that 90% is 1.645. The margin of error, he said, is 0.10. He doesn't want it to be more than that. And then does he give us anything like he observed this many out of this many? He gives us no sample proportion, so we don't know this. And when we don't know it, sometimes they give it to us, but when they don't, we go back here. We can estimate 0.5. So we'll use 0.5 if we don't know. So we'll estimate this at 0.5. So now we'll go ahead and use our formula here. So n is equal to the z, 1.645 divided by e squared. And we're going to use 0.5 here. So when we calculate this, 1.645 divided by 10, then square it, and then we can multiply that by 0.5, and then 1 minus 0.5. Maybe you know that that's 0.5, but it's okay to type it in. So we get n is equal to, oops, I made a mistake, and I see it right there. I did 10 instead of 0.10, and I know that because I know he needs to do more. So let me start at the beginning. 1.645, I did divided by 10. It needs to be divided by 0.10 squared, there we go, times 0.5 times 1 minus 0.5. There we go, 67.7. So this is 67.7, but remember, no matter what, we're going to round up. So he needs to have a sample of at least 68 cars if he wants to get within his constraints. There you go. So go ahead and give these two a try. And remember, sometimes you are going to be given p-hat and your standard deviation, but in this case, you can also use those estimations if you don't get them. Press play when you're ready to see the solution. And there you go. And that concludes 8.4.